Now second case, I'm going to remove this input signal Vs will not be there. I'm going to remove the input signal Vs and I'm going to have only the noise signal V1. So this is not going to be there. Only Vn is going to be there. So I'm going to replace Vs by a short circuit. Now you see input is given only to this A1 and this Vs is not there. Vs is going to be 0. So the overall gain will be Vn equal to Vn into A1 by 1 plus A1 A2 into beta. See, this noise will not be multiplied by A2 because you see A2 is free from noise. For A2, there is no noise source. Only A1 is going to amplify your V1. Okay, so this output will be A1 by 1 plus A1 A2 beta into Vn. So superposition theorem says whenever you have two voltage source, find the output from the two individual source and add them. So V0 equal to Vs into A1 A2 by 1 plus A1 A2 into beta plus V1 into A1 by 1 plus A1 A2 into beta. So you have two components here. The first one will represent your signal component. The second one will represent your noise component. Now I can find what is SNR. SNR is going to be given by signal to noise ratio. It is given by S by N. S means you have to take the first component Vs into A1 A2 by 1 plus A1 A2 into beta divided by noise component. Noise component, take the second term Vn into A1 by 1 plus A1 A2 into beta. Okay, so remember whenever any term is multiplied by Vs, it is going to represent your signal component. Whenever any term is multiplied by Vn, it is going to represent your noise component. Ideally, the second term should be 0, but the second term practically it can never be 0. So I'm having it as Vn into that particular term. So when you perform division, this 1 plus A1 A2 into beta will be cancelled. This A1 will also be cancelled. So remaining terms, if you group, you will get Vs by this term. Vs by Vn will be there multiplied by A2. So Vs by Vn into A2. So what is Vs by Vn? It is the SNR of the first case. So I can say Vs by Vn is SNR without feedback. We have derived previously, right? See here, SNR is given by Vs by Vn without applying any feedback. The SNR is given by Vs by Vn. So I can write Vs by Vn as SNR without feedback into A2. So you can see the SNR with feedback is multiplied by SNR without feedback by a factor A2. And A2 is going to be the gain of the amplifier. So SNR is multiplied means you know the value is going to increase enormously. So when you say SNR value is going to increase, it is going to make my system more immune to noise. So noise is not going to affect my system that easily. Even if noise is going to affect your system, when you apply a negative feedback, the effect of noise is completely cancelled. So see here, which the SNR is A2 times higher than the original case. Hence, there is an improvement in signal to noise ratio by connecting a noise-free amplifier before the noisy stage with the application of negative feedback. So one important thing, even if you are having noise connected to an amplifier, don't worry. Before the that amplifier, you connect a noise-free amplifier A2. If you connect a noise-free amplifier A2 before this amplifier A1, because of negative feedback, the effect of noise will be considerably reduced. So when you use negative feedback, so it will result in improvement in SNR. So when SNR is going to improve by a lot, which means I'm going to reduce my noise, which will in turn indirectly results in reduction of, because SNR is signal power by noise power, right? So when my SNR is going to increase multiple times, my noise power is going to be reducing, or my system is going to perform very well in the presence of noise. So any queries anybody is having, you can ask. Anybody is having doubt in noise reduction property of negative feedback, you can ask me. Remember, when you are going to have negative feedback, even the worst noise scenario, you are going to have an amplifier. That amplifier will start working perfectly when you are going to apply negative feedback, because negative feedback will completely weed out your noise. Any questions? Are things clear to everyone? Okay. So assuming that things are clear, we'll go to the next problem.